Yeah, good evening, everyone. So, joining camps. Today, let's see how Vernier calipers and screw gauge works. Small topic, but quite an important one. Advanced may they do frame questions based on errors in Vernier calipers and screw gauge. Generally, that is the reason I generally do it in the end again. We'll do it in the end again, but for now, we can just do a brief of it. Who else is missing? Huh. Let's see. Others need to keep your cams on. So, everyone played Garba yesterday. Yesterday was the last day, right? Visarjan, I suppose. Okay. So, what is this Vernier calipers? The first time I saw in college, I thought it was a small axe. I used to take this. I used to run behind my friends saying I'll kill them. And the teacher found it out. And then I got thrown out from the class. So, how does this look? I'm sure you've seen this in the lab. It kind of looks like axe. Not my fault. When you are just a 8th standard or 9th standard, you think it's an axe. See? So, I used to think it will be a good weapon. You can kill someone like this, and then you do like this, it opens up inside, and it's an evil weapon. So we even used to make jokes like that, in school, like. So let's see how to do this thing. So the main thing about vernier calipers, right? First, let me explain you what is this, and let's see what is the working behind the vernier calipers. That is important. Like what is the logic behind it? So in this thing, right, in a vernier calipers, we have this guy is your vernier scale, which is movable. So you can move this left, right, and so on. This is your main scale. Getting it? And whenever you want to use this, you can measure different things. So basically, if you want to measure the inner diameter of a cylinder, we use these two on the top. They look like rabbit ka ears. So if you have a cylinder like this, so you use the top ones to measure inner radius or inner diameter. Or if you want to measure the diameter, you can use this. So this measures this width. If you want to measure the depth, you use this tail ka part. You're getting? You can measure like that. If you have a cylinder with a cavity inside, you want to measure the radius of the cavity, use these things on the top. You want to measure the outer radius or outer diameter, you can use this. You can use this to measure outer diameter. And if you want to measure the depth of something, we use this thing. Clear, everyone? Now, how to use this, we will see that. Now, with the basic funda, right, or the basic logic behind a vernier calipers is you always need at least two scales. with a difference in length of the divisions. So how does that help? Let's see. So let's take a standard vernier calipers, then I'll teach you a non-standard one also. So in the main scale, a main scale has 10 divisions for every 1 centimeter. So 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, this. So we have 1 centimeter में 10 divisions. So 1 division is 1 millimeter. This is called main scale division. Or MSD. Then the vernier scale, you take something slightly smaller. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this thing also has 10 divisions, but this time this length is 0.9 centimeter. You take a scale slightly small. So in this 0.9 centimeter is 10 divisions. So one division ka length is 0.9 mm. So this is called VSD, vernier scale division. Clear? Then any doubt so far? So what is the logic behind this? So the main idea for vernier calipers is, let's say if you keep them side by side, and this is what you'll notice. So listen carefully here. If you got this, you actually understood how vernier calipers works. So when you take this vernier calipers, 1, 2, 3, 4, 5, 6, 7, 8, 9, let's say 10. And you take your vernier calipers ka scale. So this guy would be, so if you kiss a count here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For the main scale, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Does that make sense? The 9th division of the main scale matches the 10th division of the vernier scale. Now, यहाँ पे, tell me one thing, what is the distance between the first division of vernier scale and the first division of the main scale? What is the distance between first division of main scale and vernier scale? Point 1 mm, right?
Yes, sir.
Agreed? Because this guy is 1 centimeter, this is 0.9 centimeter. I mean 1 mm and 0.9 mm. So it is 0.1 mm. Agreed? What's the distance between the second and second?
0.1.
0.2. What is the distance between the seventh divisions? What is the distance between the seventh divisions? 0.7 mm, and so on. And finally, the 9th main scale division matches with the 10th Vernier scale division. So now look at this thing. This is the catch. If I move the Vernier calipers forward by 0.1 mm, who will match? If you move Vernier scale by 0.1 mm towards right, which division will match?
The first division.
First divisions will match, na? समझ में आ रहा है? First divisions will match. Suppose if you want the fourth division to match, कितना shift करना पड़ेगा?
0.4 to the right.
0.4 mm. So if you move Vernier by, let's say 0.6 mm towards right, then the sixth divisions will match. इतना clear है सबको? No, that is the main logic there. So how does this work? Look at this example. So example, let's say you put some object in the Vernier calipers and this is how the reading comes. So this division matches. So they'll ask you find the length of the object. Now listen carefully what it is. So definitely I know this was 5.0 centimeter. This is 5.1. This is 5.2. So clearly we can see it is definitely more than 5.2. Clearly it is more than 5.2 centimeters. Now tell me one thing, if it was exactly 5.2, how will the scale would have looked? If it was exactly 5.2,
So the Vernier scale and the main scale at 5.2 would match.
exactly would have matched there. So ये 5 था, ये 6 था, the Vernier would have been exactly like this. मतलब the zero of this Vernier would have matched with the second division of this. This would have been the same for 5.2. But here, which division is matching? So here, fifth division matches. Now you tell me, if the fifth division matches, how much should you have pushed forward? अभी हमने देखा. If the first division matches, you need to push 0.1 mm. If you push 6 divisions, then how much will you match? 0.6 mm. So if the fifth division is matching, how much you should have pushed forward? 0.5 mm. Therefore, the length would have been how much? The reading would be, or the length would be 5.2. Fifth division matches. Therefore, the Vernier moved 0.5 mm from 5.2 centimeter. Therefore, the length of the object, whatever you kept, is 5.2 centimeter plus 0.05 centimeter, 5.25 centimeter. Is this making sense? If it was exactly zero, this thing, zero of Vernier would coincide with 5.2 exactly. But it is not coinciding. Is this example making sense? So the whole concept of Vernier calipers is, right, Venkatesh, cams on, Palaksh, that you took two different scales and you made sure there's a small difference between the divisions. And whenever you push by the 0.1 mm, one division match, if you push 2 mm, 0.2 mm, second division matched, and so on. So you're using this concept of small difference to figure it out, that if it is exactly 5.2, the diagram should have looked like this. But your 5.2 is fine, but you're matching with the fifth division. So I'm pretty sure from here you have moved 5 divisions forward, isn't it? 0.5 mm. That's where the fifth division started matching with the main scale. Is this logic clear? Let me give you one more. You tell me what is the answer for this. This is matching. Let's say this is 7 centimeters. Now, what are the answers for these two? The black one is Vernier scale. मतलब समझ में आ रहा है क्या कर रहा हूं मैं? This is what is happening. See, if there was no object, did you see this thing moved? ना दिख रहा है यहाँ पे division. Can you actually tell me what is this reading here? I know it is a little difficult to see, but can you tell me what is this division here? Where is zero of the Vernier calipers here? ये zero है ना? So it is definitely 2 something, and then ये match हो रहा है roughly. So this is what 2 plus 0.5 mm, isn't it? 2.05 centimeters. Making sense what I'm saying? How does this look? If there was no object between them, na, this zero would have matched with exactly this zero here. So whenever you keep the object there, this thing will move towards the right side and the divisions will match. क्या था answers? Let's see. See, first one thing I'm sure, it is 7.1, 7.2, 7.3, 7.4, 7.6. इतना तो पक्का 7.6 था. Plus 1, 2, 3, third division is matching. That is 0.03 centimeters. 7.63 centimeters. This guy is 3.5. Fourth division is matching 3.54 centimeters. You can see and tell the answers. Making sense? Clear, everyone? So the general formula for this thing, right? So the main concept behind vernier calipers is, so the main idea behind working of vernier calipers is that we need two scales. You need at least two different scales. Of different length of the divisions, with different length of the divisions. And the difference is used to measure the difference will actually give you the accuracy. The difference between the lengths can be used to get more accurate values. So you can actually construct Vernier calipers in different ways. So main thing is that if you have two scales of different length, you can make a Vernier calipers. So the general formula for this thing is the length is given by main scale reading plus n into least count. This is the main scale reading. N is the number of divisions that is matching. L is called least count. So least count ka definition is the smallest measurement the instrument can measure. Then we also define something called Vernier constant, which is one main scale division minus one Vernier scale division, right? And generally both are equal. We'll see later on what it means. Generally, a least count is equal to Vernier constant. Have a look at this. Now let me show you what they asked in advance. ये तो standard formula है. Mug up करेंगे answer आ जाएगा, but advance में they don't ask like this. They really expect you to know how the hell the Vernier calipers is working. But all got the idea here?
So can you go back for a minute?
I'll go. Hmm.
Yes, sir, thank you.
Hmm. Right. This was actually J advanced question. And I don't remember the year, but last 5-6 years में आया था ये. So we don't use a standard Vernier calipers every time. तो standard Vernier calipers क्या था? तो example दिया था ये standard है. So let me write down here. This is the standard Vernier calipers. Hope you know how to do, or you just remember the answer. Try. Okay. Think, others try. I'll give you a minute more. Okay. See, so the catch here is the first one. There are two Vernier calipers, both of 1 centimeter divided by 10 divisions on the main scale. The Vernier scale of C1, 10 divisions equal to 9. So the first one you're talking about, there are two different Vernier calipers here. Look at C1 ka Vernier calipers. In C1, 1 centimeter is divided into 10 equal divisions on the main scale. So one main scale division is 1 mm. One Vernier scale division, the Vernier calipers of C1 has 10 divisions for 9 centimeters, so 0.9 mm. So least count is 0.1 mm. But for C2, one main scale division is 1 mm, whereas one Vernier scale division is 1.1 mm, because 11 divisions are matching with this thing. So here the least count is minus 0.1 mm. Getting it? So the first one, you'll give you the standard answer there. So the first one ka answer would be, it is 2.5, 2.6, 2.7. This is 2.8. And it is roughly matching, meaning sab dikh rahe 7 karke, it is matching with this guy. So this is 2.87 centimeter. The first one is standard one. So C1 is the standard Vernier calipers. The second one is non-standard. You're getting a negative least count. So what is happening here, see? So in this Vernier calipers, when I keep them side by side, again, basic, the same concept if you use. So this is your main scale division. Look at the Vernier scale division, how it looks. This is the 10th division of Vernier matches with the 11th division. Fair enough. Least count is simply one main scale division minus one Vernier scale division, no? Least count is main scale division minus Vernier scale division. So it is 1 mm minus 1.1 mm, right? But let's see what is the meaning of that. Now see, what is the difference between the first division and the first division? 0.1 mm, right? But this time you tell me now, if I want the first division to match with the first division, which way should I move? Difference between the first divisions is 0.1 mm. So if I move the Vernier scale backward, If we move Vernier backward by 0.1 mm, then first division will match. You should not move right side, you should move backward. And यहाँ पे we can clearly see the 7th division is matching. So for 7th division to match, I'll give you a general formula, but you should know why it is working this way. For 7th division to match, we need to push 0.7 mm backward. Making sense, everyone? Is the logic making sense? Clear? Now, coming back to that diagram there, 4, 5, 6, 7, 8, 9, 10. Our Vernier calipers was 2.8, 2.6, I am not drawing up to scale 1, 2, 3, 4, 5, 6, 7. So this division was matching. Now you tell me exactly. If it was exactly 2.8, how it would have looked? If it was exactly 2.8, how it would have looked? It was exactly 2.80 centimeter. Then the scale ka diagram would have looked like this. The vernier would have been started from here. Agreed? But abhi ye batao, if I move this guy 7 divisions backward or 0.7 mm backward, will the scale be still at 2.8? Won't it become 2.7 plus something then? You're getting it? If you move from here backward, this was 2.8. So for 7th division to match, we have to move it 0.7 mm backward. For 7th division to match, this is all more intuitive. There's no big concept there. We need to move 0.7 mm backward. But then the scale would look like this. The scale would have started from here, where this was 2.8 and this was 2.7. You're getting what would have happened? So then the answer would have been 2.7 plus something. Therefore, we should move it from where?
2.9.
We should move from 2.9 centimeter. समझ में आ रहा है? If you move from 2.8 and go backward, you will go into 2.6, 2.7 and 2.8 का बीच का division से start हो जाएगा. But if you move it from 2.8, then it works out. So if you move it from 5, 6, 7, 8, 9, 10, 2.9 centimeter, this was exactly matching here 0, and now you move backward by 0.7 mm. Then you will get what you're asking for. So then the reading would be 2.9 centimeter minus 0.7 mm or 0.07, which is 2.83 centimeters. See the answer. Again, listen, the whole story is that only. Vernier calipers, initially what happened, whenever you wanted the divisions to match, you had pushed it forward, isn't it? But यहाँ पे, because the vernier scale was become bigger, you have to push it backward. So from 2.8, if I push 0.7 mm backward, मेरा scale start होगा 2.7 plus something, but that is wrong because I'm pretty sure my scale is between 2.8 and 2.9. That means you're not moving from 2.8, but 2.9 से पीछे push कर रहा था. Is that making sense? So whenever you're having negative least count, this is the formula. You can remember this exam में, you should know how it works though. So for positive least count, the general formula works. Length is equal to main scale reading plus n into least count. For negative least count, length will be main scale reading plus 10 minus n into least count. And this is again under the assumption main scale has 10 divisions. कोई guarantee नहीं है main scale का 10 divisions होगा. I can mess up that also. So remember the basic thing how to do. Clear with this? Please ask me if you're confused here. Next one. Let me give you one more like this. Numbers might be bad, but I just wanted to get the working. I'm not sure about the actual numbers though. So let's say we create something more weird one. So we got a scale, main scale. Let's say 1 centimeter has 8 divisions. The Vernier scale. रुको ऐसे 1 centimeter ना 20 divisions लेते हैं. For Vernier scale, let's say 1 centimeter, 15 divisions. Second one, say main scale 1 centimeter, 20 divisions. Vernier scale 1 centimeter is 25 divisions. So there are two scenarios like this. So main scale का 20 divisions है ना? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. मतलब half of mm का divisions था ये. And your Vernier calipers is looking like this. This guy is matching. What is the reading using both the Vernier calipers? This is Vernier calipers 1. This is Vernier 2. If I use these two Vernier calipers and if I measure something and reading ऐसा दिख रहा था, what is the reading? What is the value measured by both of them? Numbers might be either or, but get the concept. What do you guys think? फोर कहाँ से आएगा रे गॉड? दिस इज डेफिनेटली कितना था ये? 1 2 3 4 5. This is, remember, each division is how much? One main scale division is 1 by 20. That is 0.05 centimeter or 0.5 mm. So how much is this? 6. This is 6.05, 6.10, 6.15, 6.2. This is 6.25. This is 6.50. Suppose this guy is 6.3, 6.35. This much I'm sure. Isn't it? 6.35 plus something tha wo. What is one Vernier scale division? 1 by 115. That is definitely much bigger than this. So you'll get actually a negative least count. So least count will be 1 by 20 by 1 by 15. This is minus 5 by 20 into 15. The minus 1 by 60 centimeter. ये least count था. So from that formula now, what should you do? You should actually take 6.4, and it is matching with the how much, what division here? I'll leave the question separately. Huh? So it is matching with what division here? 1, 2, 3, 4, 5, 6, 7. Means how many divisions should you push it backward from? You should push 7 least count backwards, na? कहाँ से push करना था? So we have to push it from 6.40 minus 7 times least count. Is that making sense? Because अभी देखो ये formula valid नहीं होगा because 10 minus n कोई guarantee नहीं है. I made 20 divisions. You messed up the whole formula. If you try to use this, you will get trapped. But if you actually know why you have to do this way, you will understand. So you have to move the scale not from 6.35, you have to move it from 6.40 minus 7 least count. That would be 6.40 minus 7 by 60 centimeters. I know number is not that great, but that will be the answer. कितना होगा roughly ये? Maybe I should have given fifth division. No? That would have been better, I guess. But ठीक है. 6.40 minus. This scale is not proper actually. 6.83 आ रहा है. I know I goofed up somewhere. Maybe it shouldn't have. Third, seventh edition should have matched. Wait, I'll just change the values. Like I said, ना values अच्छे से देखा नहीं मैंने. This is not a regular scale. I just give you something randomly. I'll just adjust. 3. एक काम करते बेटा. I'll just change the question here. I should actually check the numbers more carefully. You would have got it, but मैंने just randomly कुछ भी number दे दिया तो it is not working now. Let's say this second division matches. Then this guy will be 2 times least count. And this will be 2 by 60 centimeters. This thing is coming out to 6.36. There. Because you can't get less than 6.35. I'm pretty sure it is 6.35 plus something. So that means the scale, it will never match at the 7th division in this way. It is wrong. I didn't do it properly. But I hope you got the concept. कैसा करना है. You always check the next division and subtract from there. B का क्या होगा? B is a standard Vernier calipers. One main scale division will be 1 by 20. One Vernier scale division will be 1 by 25. So यहाँ पे reading will be 6.35 centimeter plus 2 into least count 1 by 20 by 1 by 25. That's your answer. कितना आएगा वो? 25 minus 5 by 1 by 100 तो 2 by 100. 6.37 centimeters. Clear, everyone? So there. So this Vernier 1 is a non-standard Vernier caliper. So be careful. This is a negative least count. Clear? Next one. Any doubts on this? But everyone got the basic idea? So the simple thing, na, kabhi bhi negative aata hai, take the next division from there, you subtract it. If you get positive, use the regular stuff, you'll get the answers. But I hope everyone got the working of Vernier calipers. Great.
To calculate one main scale division or one scale division, we just divide
1 by 20, na? Why
always, right?
Always.
Oh.
Why length hai na? 1 centimeter is 20 division. So 1 division kitna hoga? 1 by 20.
So if it's 9 divisions, so it's
1 by 9.
Oh, thank you.
वो नंबर अच्छा नहीं होगा इसलिए नहीं दिया मैंने. थोड़ा ध्यान से numbers बनाएंगे तो you'll get good questions, but concept is important. They can't play more than that in this. Suppose if I have something like this. Let's say one main scale division is 0.5 mm. One Vernier scale division is 0.3 mm. Again, I'm giving some random numbers. Find the least count and Vernier constant. दोनों same नहीं है. Look at the definition what I wrote here. Least count is the smallest measurement you can make. Vernier constant is one main scale division and is one Vernier scale division. They look same, they're not. What do you guys think? Right, Yasha, you got it. Just give me a minute, I'll be back. Let's see. Let's see. 0.3. Now, what is Vernier constant? वो direct था. Vernier constant is one main scale division minus one Vernier scale division. So that would be 0.2 mm. But what is least count? The smallest you can measure. Now see, the smallest you can measure. If you try to draw the scale, you'll understand. If you try to draw the main scale, एक division 0.5 mm है ना? So this is the first division, second division, third division, and so on. The first, second, third, fourth, and so on. This is the main scale. Now understand, okay, the smallest that you can measure. कुछ भी करो, what is the smallest you can measure? Here, if you look at the first division, this guy will be somewhere here. The first, 0.3, 0.3, ये होगा. Second, then नहीं, I went too ahead actually. 0.3, 0.3, तो यही कहीं पे होगा. Second, and this will be third. Now, what is the difference between the first and the first? Difference between first divisions is how much? 0.2 mm. What's the difference between the second divisions? How much is the difference between the second divisions there? Can you tell me what's the smallest difference between two divisions here?
0.1.
Difference between second and third division, देखो, you'll see easily. Difference between second main scale and third main scale division. Third Vernier scale division is how much? 0.1 mm. Agreed? That means if I move the Vernier calipers by 0.1 division, I know the third Vernier calipers का division will match with the second. So what is the smallest you can measure? 0.1 mm, right? समझ में आ रहा है? The smallest you can measure is 0.1 mm. Is this making sense? So Vernier constant need not be least count every time. So when we move by 0.1 mm, second MSD matches with third VSD. Therefore, least count is 0.1 mm. So be careful. Is this clear, everyone? So if you see, the entire thing is more of intuitive thing. All clear? Rehan, Ronak, Venkatesh, Adrit, Mehan. Anika, clear, na?
Sir,
हाँ रे, उदयन.
sir, if we move by 0.2 mm, then which division will match?
0.2 move करने हैं तुझे. First division match करेगा. First will match with the first division.
Okay, okay.
Na? First VSD will match with first MSD. Next one. Let's say someone made two scales. Someone took two triangles and they divided them into equal divisions like this. ये angle theta था. This is D. These are equal divisions. I'm not drawing them properly again. D, D. So two identical scales are given like this. These are some weird scales. Two identical triangles, right angle triangles, with the divisions as shown are given, identical. How do we construct a vernier calipers and what is the least count? अभी इन दोनों को यूज करके आपको वर्नियर कैलिपर्स बनाना है एंड उसका लीस्ट काउंट कितना होगा? The whole concept of vernier calipers is you need two scales of different lengths. How do we do this? Did you find two scales? So these are the divisions, na? You can keep the other guy like this. अभी देखो क्या होगा इसमें से. So you have created a scale like this. So this is one scale. The hypotenuse is your second scale. You're getting? Your hypotenuse will be a scale with bigger divisions. देखो ये बड़ा divisions है. So by moving this front and back, you can create the two scales basically. So the base, so use base and the hypotenuse as two different scales. So for this guy, the hypotenuse ka, if this is theta, this guy will be d sec theta, and this guy will be d. So least count will be d sec theta minus d. That's the smallest you can measure. यानी कैसे measure करेंगे पता है? You take the object here and keep it here. Then you use the scale like this. समझ में आ रहा है? And then from there we can slide it on the base and then we can create a scale. Then this will be the 0 here. So somewhere you get the readings here. And some revision of that will match. So we can do like that. Clear, everyone? Next one. Easy? Now, sometimes what happens, Vernier calipers, right? Kids play with it a lot and they mess it up sometimes and you have errors. So we have two types of errors in Vernier calipers. The first one is a positive error. So if you take a scale without any error, this is how it looks. Your Vernier ka 0 exactly matches with this guy. And like this. So 0 of the Vernier matches with the 0 of the main scale. In this case, there's no problem. We have a positive error. In this case, what happens? This number is slightly forward here. Let's say the second division is matching. Means what? Even when there is no object, you're showing two divisions, isn't it? 0 of Vernier is ahead by two divisions. 2LC. That is, it is showing two least count more even when there's no object. Two least count more without object. So therefore, what will be the reading? The reading will be the main scale reading plus the number of divisions minus, in this case, you have to take 2 because the number is that. So the error will be correction here. So it will be number of divisions matching n minus 2 least count n minus 2 into LC. Example. Suppose if I use this scale to measure, let's say this is 6 and this is 7. This is matching. So क्या होगा आंसर इसका? So this is a positive error and a negative correction. So reading would be 6.3 centimeter plus 4 minus 2 into least count. That would be 6.35 centimeters. No, 6.32 centimeters. Clear? I'm taking this one as an example. So even when there's no object, you're getting 2 least counts more. तो आपको जो भी फाइनल आंसर आएगा उसमें -2 least counts subtract करना. All clear with this? Any doubts on the positive error part? Everyone clear? In this, the negative error is a catch. Negative error कैसे देखेगा? Negative error the Vernier calipers का 0 will be behind. And let's say the third division is matching. तो correction क्या होगा? This is a trap, huh? इसका क्या होगा? We are just taking standard Vernier calipers. Let's go back to the basic thing again. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So your standard Vernier calipers now was like this. Ten is matching with me. Now you tell me, if I move this backward by 0.1 mm or one least count, which division will match? First match नहीं करेगा. कौन सा match करेगा? Ninth will match ना. Ninth of Vernier will match with 8th of main scale. समझ में आ रहा है? If you push it forward, then 1 and 1 will match. But if you pull it backward, this guy, this 9th will match with this 8th here. You're coming backward, isn't it? So if I move it backward by 3 least count, can you tell me who will match? 1 के लिए 9 मैच हुआ, 2 के लिए 8 मैच होगा, 3 के लिए 7th ना. 7th VC matches with whom? 6th MS. So if you move 7 least count, then who will match? 3rd na. Are you getting this? That means when this guy is actually showing negative, can you tell me how much less it is showing? This is showing not 3, huh? This is showing it is showing 7 least counts less than actual reading. So negative error में the correction will be 10 minus the number of divisions matching. This is the correction. It is not 3. Are you getting the logic there? तो यहाँ पे correction 3 times least count नहीं है. You should not do +3 LC. You should do +7 LC. Because if you want 0 to 0 match with again, you need to push it 7 divisions forward. Is this making sense? Basically, the 0 of Vernier matches 0 of main scale if it is pushed 0.7 mm rightward. All got this? So example. ये फोर्थ रिवीजन मैच हो रहा था, इसका रीडिंग कितना होगा? नेगेटिव एरर, तो इसका रीडिंग कितना होगा? So I know it is 3.6 centimeter plus 4 divisions plus 7 correction least count. That would be 11 0.11 3.71 centimeter. 3.71 ना? नहीं sorry 3.5 था ये. Yeah. 3.61 centimeter. Agreed? नहीं? This is 3.5 centimeter. That is 11 into this thing, na? So 3.50 into 0.11, 16.3. Please check. Everyone clear with this? Anusha, Aryan? Clear? Anyone confused? Anyone not clear with this? Neil, Vidyut, clear with this? Abhinav, Mehan?
So can you explain that 4 plus 7 वाला part again?
देखो ना, error यहाँ पे 7 least counts है ना?
हाँ.
So यहाँ पे reading कितना था? 4 दिख रहा था, but correction कितना था? +7, right?
Yeah.
Means whatever reading मुझे आया, उसमें 7 least counts कम दिखा रहा था. So I need to add +7 LC ना?
Okay.
Meaning I'm using this as an example. Fair enough?
Yeah, understood.
All clear with this? There, that is about Vernier calipers. So they can play around like that. And then we have screw gauge, which is a little easy. Let's say that. Vernier calipers is the main one. You can play a lot of, you can mess it up. Screw gauge really can't do much. You can do if you want, but let's not do it right now. How does your screw gauge look like? So this is a screw gauge there. Let's say I think I have a better photo. You can call it Vernier scale, you can call it main scale. So this is your main scale. This is your head scale. You have a दूसरा Vernier scale also, ठीक है. So let's see the working behind it. The idea is pretty simple there. If you ever see a screw, right? The screw, this is a screw ka threading. The distance between two screws is called one pitch, just like a helix. This is a helix ka shape. So what happens with a screw, na? Yeah, threading. The grooves are called threads, screw ka threads. So here the idea for a screw gauge, na? If you move one rotation, whenever you rotate the full screw by one rotation, the screw moves by one pitch. So if there are n divisions, in one rotation. Then one division will be pitch by capital N. That means the smallest measurement you can make is one division. Least count is basically one head scale division. This is the one division of the screw, okay? One division of one head scale division. So the idea is pretty simple. If you make one full rotation, you get one pitch. If you move only one way, this thing, you'll get 1 by n, the pitch by total number of divisions. Example. Normally, this is how it looks. So this is your head scale division there. 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, something of this sort. And here you have the head scale divisions like 0, 1, 2, 3, 5, ऐसा. This will be like 95. So let's say on the head scale, the divisions are like this: 0, 1, 2, 3, so 99, 98, and so on. So let's say the divisions are like this. Actually, reverse, I guess. 1, 2, 3. So this will be like 99, 98, and so on. So when you move it, you'll see 1, 2, 3, ऐसा. The divisions will go like this. And let's say it is given the pitch is 1 mm. So they'll give you the pitch. What is pitch again? Difference between two threads. Number of divisions is 100. So least count will be 1 by 100. So 0.01 mm. Now logic dekho kya hai. So when you put an object between these things, you keep an object here, and when you tighten the screw, you'll get a sound like kar kar karke sound aayega. Matlab it has become tight. It is not becoming tight anymore. And let's say the reading looks like this. This is what you saw. इसका मीनिंग क्या था? You're seeing 0, then you saw 3 lines. How much is this? This is 3 mm, right? So this is 3 mm. Because definitely I'm sure there are 3 divisions. 3 mm plus 36 head scale divisions. So this guy is 3 mm plus 36, and one head scale division is 1 by 100 mm. So this is 3.36 mm. Easy. अब logically सोचो ना, if you had completely rotated and if you got 0 here, इसका मतलब क्या? You would have seen the 4th division, isn't it? If you had completed 4 complete revolutions, you would have seen a 0 again. But you're seeing only 3 divisions, and the 4th division is not visible, but you see 36 number. Is this making sense? Let me give you one more example. You try this thing. Let's say one pitch is 1 mm. Basically, one pitch is nothing but the main scale division. Number of divisions are 50. इसका लेंथ कितना था? So this I'm sure it is 6 mm plus 40 head scale readings. 6 mm plus 40. One head scale reading is 1 by 50 mm. 0.8 na? 6.8 mm. 80. Easy. So the general formula is, this is more easy than Vernier calipers. Vernier calipers is more messed up. The reading will be main scale reading MSR plus the number of head scale divisions, head scale reading into least count. Clear? Any doubt so far? Please ask. The last thing, errors. So in this also we have errors. When you exactly see 0 here and 0 here, meaning zeros match. There is no error here. There is no object. If you have a positive error, it will look like this. Let's say there are 100 divisions, okay? What is the meaning of this? You can see 0 outside, but it's showing 36 even when there's no object. Means it is showing how much more? It is showing 36 divisions more. So the reading will be, जो भी main scale reading आएगा, main scale reading plus head scale reading minus 36 into least one. Fair enough? You just subtract it. You're showing additional. This is a positive error. What is a negative error? This is interesting again. Negative errors are always catchy. Negative error में you can't see the 0. 0 will be inside. That is how you know it is a negative error. 0 of main scale is not visible. And you see 36. What is the correction? If you rotate the screw in the reverse, what is the first number you will see? See, this is 0. Rotate किया तो क्या दिखेगा? 1. Rotate किया तो 2, 3 ऐसा दिखेगा ना? But if you go reverse, before 0, what will you see? 99. 98, isn't it? If you're rotating in the reverse, you will see numbers in the reverse, na? 99, 98, 97, 96, 95, and you went to 36. Means how many divisions you rotated in the backward direction? 64, right? Means you want to get 0 back, you have to rotate 64 divisions forward. Are you getting the logic? If we rotate screw in the reverse direction, we see 0, uske baad we'll see 99, then we will see 98, and then so on, we'll see 36. That is, we rotated 64 divisions. It's not 36. So it is showing 64 divisions less. Therefore, reading will be main scale reading plus head scale reading plus 64 for this example into least count. ये negative errors का थोड़ा ध्यान रखना. Vernier calipers and screw goes, they do mess up. Clear? Check it out. That's the last one for the day. So these are the main ones, Vernier calipers and screw goes. Do check this out. Again, once the portion gets over, we're again going to do this again once more. Thoda, it's an important one, like I said. There we will include errors also. इसमें add करके then we can do. And generally remember, least count is the error. Okay. So there, that's the last one for the day. So Friday will not be having a class. Any doubts, anything, right? You can stay back and ask. And whatever doubts you can send it before tomorrow night, 9 o'clock. I'll give you a slot. Right. And try to finish off physics early. So Friday you can sit and study your chemistry. Okay. So with that, we'll wrap up for the day. So any doubts, anything, stay back and ask. Also free to leave. So I'll see you again directly next Wednesday, 6 o'clock. Okay. Any doubts in today's class? Anything else you can ask? Also free to.